As you get down to problems 4, 5, and 6, they're kind of random. Sometimes it's implicit differentiation. Sometimes it's area. Sometimes it's a straight up related rate problem. Sometimes it's a derivative problem. Sometimes it's a slope field. Sometimes it's particle motion. We already did particle motion. We did a velocity acceleration problem. So let me say this. Every year the exam has been in existence, there's particle motion. We've already done a particle motion problem, so there's probably not going to be another one. All right, here we go. This is going to be, just from the looks of it, I just glanced at it for less than 5 seconds. This is going to be an area volume problem. I'm going to teach you how to do volumes tomorrow. It says, let f be the function defined by f of x is equal to 6 divided by 1 plus x squared. Anytime you go 1 divided by, or anytime you divide by 1 plus x squared or 2 plus x squared, it's like a bell curve type deal. All right, it says, let R be the shaded region bounded by the graphs of f and the horizontal line y equals 3. Now, here's what Molly might say is, how do I know which function's which? Because I need to know the top function and the bottom function. Well, we know which one the horizontal line is. We know this is y equals 3. So then you know this is function f. So which one is the top function? F. So when I do area between two curves, Autumn, we're going to go what? Top minus bottom. And that's all they want for part A, and I've got good news. It is worth 3 points. All right. Now, here's the part you don't know. Blake does not know this yet. We're going to go the area for region R. If you want to do the volume of region R, we know it's going to be, if I want to do area of region R, it is going to be the integral from A to B of the top function. What's the top function? F of x minus the bottom function.
Let's call it
Y'all make it way too hard.
Why?
3.
Okay.
Where did y come from?
Yeah, we're not doing y's. Everything's in terms of x. Well, but we want it in terms of x, so we want just the 3. So f of x minus 3 dx. Are you good? Okay, you're going to like this. That was worth 1 point. Okay? Actually, no, not yet. Because what am I missing here that I haven't done yet?
The AB.
The A to B. I don't know what the A to B. Okay, plug in that's what you meant by plug in the numbers. All right, so the A to B. Shh. So here we go. We've got, no, you cannot assume anything. I do not know what these numbers are. And some of you might be, maybe it's what? You don't know that for sure. You got to solve it. So I need to know, I think it's from -1 to 1, but I don't know for sure. How are you going to solve this? Because there is 1 point for this. How do you do this? There's no calculator. How do you do this?
You plug it in.
Come on, guys. Yep, the equation. Come on, look. You have, thank you. You're going to take f of x. You want to see where f of x crosses what? 3. So I need to take f of x. I need to literally take f of x, which is the 6 over 1 plus x squared. I'm going to set it equal to 3. So I'm going to take 6 over 1 plus x squared, set it equal to 3. I don't want the x in the denominator, so talk to me. I'm not going to tell you how to solve this equation.
You gotta multiply by 1 plus x squared.
Thank you. 6 equals 3 times 1 plus x squared. Distribute the 3. We'll get 3 plus 3x squared. All right, or you could have divided by the 3. Would anybody thought to divide by the 3?
I would have.
And say 2 is equal to 1 plus x squared? That'd probably be easier. But if you distributed the 3, will it still work? Yeah. Now what do you do? Minus the, what? I divided by the 3, so mine's a 2 now. Okay, so what do you do now? Minus the 1, so you get 1 equals x squared. Now what do you do? So what does x equal? Plus or minus 1. There's your limits of integration. So it is -1 to 1, but don't assume it, because I've seen years where it's been like 0.95 to 0.95. And then in that case, they probably won't actually have you do the integral. They'll just have you set it up. Okay? It is a point now if you have this. F of x minus 3 dx. Now, you need to find the area. They said find the area. They didn't say write an integral. So here we go. We have 2 more points to get. All right. We need to know what f of x is. What is f of x? What was the equation?
6 over 1 plus x squared.
Now, here's what I'm going to do. I'm going to tell you the best strategy to integrate this if you're on the free response. I'm going to do it step by step, slow. A lot of you are like, I can do this integral, 3dx, no problem. Would you agree that's going to be easy? And I'll show you 2 ways you can do it in a second. But this is the part you're going to have a hard time with. Would you agree?
Yeah.
One of the reasons you're going to have a hard time with it is because in a second, I'm going to tell you it is going to be one of your calculus essentials that you have memorized in reverse. And I'm going to tell you how you can see it because it is quite simple.
Was that like the arcane?
Thank you, Jesus. Take the wheel. All right, here's what I would do. I would split the integral. Watch this. I'd split the integral. And I would bring the 6 out front. Because now I bet everybody sees it. This was one you memorized in your calculus essentials. It's the only arc one you're going to have to know in reverse.
Guys, raise your hand if you see it.
Well, you did, and you saw it without the 6, so I'm confident they see it. Minus, now this one you split. Is the 6 with the next one?
No.
That's why I have an integral here from -1 to 1 of 3dx. We'll get to that part in a second. Okay, now, so we're going to have 6 times arctan. They usually have one arctan problem on the exam. And it's going to be something just like that. And it throws you off because of the 6 on top. But if you take the 6 out, you should be able to see it. Oh, yeah, that's just the integral rule, or the derivative rule. The derivative of arctangent was 1 over 1 plus x squared. Evaluate from -1 to 1. We'll have to do some unit circle work there in reverse. Minus. All right, now there's 2 ways you can do this. There is a shortcut, and then there's FTC. If you want to integrate this and get 3x evaluated from -1 to 1, you can. You can totally do that. But since it's the integral of a constant, does anybody remember what the shortcut was when you integrate a constant with the limits of integration? You're finding the area under a what?
Line? Horizontal line?
So it's a horizontal line from -1 to 1. So isn't it just a what?
Square rectangle.
Rectangle? Isn't that the height of the rectangle?
This will be 6.
Isn't that the width of the rectangle? How wide is the rectangle? 2. 2 times 3 is what? There it is. But let's say you had a brain fart and you forgot about that because you guys haven't slept a lot. Okay. What's the integral of 3? Is it still going to give you the same thing?
Yes.
Does it still give you the same thing? But if you integrate a constant, all you have to ever do when you integrate a constant with a definite integral is just say, oh, that's the height of the rectangle. This is the width of the rectangle. Just multiply width times height. That's a property. Okay, so that's 6. Now we're going to go 6 times arctan. Here we go. Cue up Blake. Arctan of 1 minus arctan of -1. Good luck, Blake.
So much Bob. I had a 19.
All right, be quiet. What's arctan of 1? Where does tangent equal 1? At root 2 over 2s, but what's the angle? That's correct. Pi over 4. That's quadrant 1. Now, where's arctan going to equal -1?
This is crazy.
That one's tough, man, because you guys haven't done this in a while, and there's restrictions for arctans from pre-calc, or from trig. Thank you. It's from -pi over 2 to pi over 2. You remembered that from last year.
Pi over 4.
Yes. Did you do it too?
No, I was just excited for Logan.
That is crazy. So it's not 3 pi over 4. It's what? No, it's not 7 pi over 4. It's
-5.
It's negative pi over 4. The restrictions from trig class, if you took trig with me, is negative pi over 2 to pi over 2. So if you're going negative pi over 2 to, remember, arc sine, quiet. You're only going to do arc tangent. This is the only one you got to know for the exam. Arc sine was also negative pi over 2 to pi over 2. Arc cosine was what? 0 to pi. Very good. Arc tan is negative pi over 2 to pi over 2. So you go quadrant 1 this way, or you go quadrant 4 clockwise. So that's why it's negative pi over 4. Okay, so we're going to have we're going to have 6 times pi over 4 plus pi over 4, which is going to be 2 pi over 4, which is pi over 2, minus 6. So we're going to end up with 3 pi minus 6 is the area of the region. That's worth 3 points. Now, here's the good news. Here is the good news.
That's gotta be there.
3 points. Here's 1 point for you doing this. Look at it. 1 point for that. 1 point if you do the antiderivative correctly. So if you just do the antiderivative correctly and don't even calculate the area correctly, you can get 2. Third point will be that.
Was that all part A?
That was all part A. Now, good news. I need to stop now because you're on my time. Okay? Stop throwing stuff. Stop distracting. Write but do not evaluate an integral expression for the volume of the solid generated. All right, this is the formula. Let's see if you can pay attention. You have them memorized. Let's see if we can at least get the formula down, and I'll show you how to get it. Okay, when it's rotated, so this is a volume of rotation. It's rotated around a horizontal axis of rotation. Who wants to tell me the formula? Go ahead.
Method?
Pi over integral
Integral,
AB
A to B.
RY
Well, if
of
it's
big R
big R,
of Y squared.
is it going around a vertical axis of rotation or horizontal?
Did I say Y?
So it's going around a horizontal axis of rotation, so is it R of X or R of Y?
X.
R of X.
Squared.
Squared.
Minus little r. Squared.
Now,
Dude, Logan, this is the.
you had it. You had it on the calculus essentials. Memorized it. Okay? All right. You missed those. That means you missed 8 of them. All right. So here we go. Now, if it's not a washer, now tomorrow I'm actually going to teach you this. This is the washer method. There was also the disc method. That only has a what? Outer radius. Here's how we're going to tell. We're going to go up here. Detloff's going to go up here. He's going to draw y equals 7 is. Where do you draw the horizontal line y equals 7? That's 7. Right there. Does everybody see it? We're rotating around that. Are you flush with what you're rotating around, or is there some white space? Then you know it's a washer. So all you have to do, you do not need to know what this looks like. It's wild what this thing looks like. It's like a crazy looking yo-yo with a hole in it. Okay? It's like one of those yo-yos where it's like warped out, that's bigger ones that are funneled out, you know, and you know what I'm thinking about? But there's a hole in the middle of it. Okay? So this thing, look, this thing is getting rotated. It does not matter if you know what it looks like or not. Tomorrow I'm going to show you, and it's going to be magical, and everybody's going to be like, oh my gosh, I finally know what you're talking
Is it
about.
like a tornado?
Sure. It goes around like this. It's going around like this. It's rotating. I don't care if you know what it looks like. You don't need to know what it looks like. To be able to do the problem, you don't have to know what it looks like. I'm not visual enough to know what it looks like, and I don't care what it looks like. All I've got to be able to do, girls, all I've got to be able to do is do an outer radius. You always, most important part tomorrow, I'm going to hammer this tomorrow. You always measure the radius from the axis of rotation. You're rotating around this. So the outer radius will be from there to the furthest away. And you're going to do top minus what, everybody? So big R of X, everybody watch this, big R of X, this is crazy. Big R of X is going to be the top function, which is what? Don't make it hard. What's the top function? 7. Where are you getting 6? Okay, I'm measuring this dot. 7 minus the bottom function. What's the bottom function at? 3. What is the outer radius then? That's the outer radius. Now, that would just be, if we did not have this white space right here, it would just be a tire. But because they carved out this white space, like you're taking this white space out of the tire, you're cutting that out and rotating it. Okay, if this was filled in completely, you would just have this rectangle you're rotating around and form a hockey puck or a tire, whatever you want to call it, a cylinder. So now I got to do the inner radius. I'm telling you, you can do this. These are not that hard once you figure out what to do. Tomorrow it'll make a lot of sense because I'll actually show you everything. There's the inner radius, top minus bottom. So what is the inner radius going to be? What's the top function again? 7. Minus the bottom function. No.
Is this one
5.
6?
Looks like a little bit below 5.
You don't need to know the number. It's a function.
Oh, we're going to put the function in.
Yes, f of x. Because it's changing. It's not always going to be that. Because remember, there's an infinite number of rectangles, which makes an infinite number of discs. Okay? So there, you've got your outer radius, you've got your inner radius, and here's the best thing about part B. It says write, but do not what? And it's still worth 3 points. Here we go. And if you get, ready, here's the best part. If you get the pi from -1 to 1 right, that's 1 point. And if that's all you can do, you can be like, I got 1 point. Now if you do the outer radius, what was the outer radius? 4 squared minus, there's another point. Minus what? There's your other point. There's 3 points.
You don't gotta like simplify?
It says right, but do not what? You are done. That wasn't so bad. Part C. Now this one's worth 3 points, and this really has nothing to do with volumes. Okay? It says, let h of x, okay? Let h of x be the vertical distance between the point 0 or x f of x. So they're talking about a point on the graph of f. Let's remind ourselves, f of x was this 6 over 1 plus x squared. Does everybody agree? So we're talking about points on f of x. And let h of x be the vertical distance between points on the graph of f and the horizontal line at what? 3, okay? Find the rate of change of f of x. What does it mean to find the rate of change of h of x? They didn't say average rate of change. They just said rate of change. IROC. What's IROC? Instantaneous rate of change, which means take a what? So we want a derivative of something. What do we want the derivative of? The vertical change. So how do we do the vertical change? It says the vertical change between this and this. I'm going to say it again. It's the vertical distance between this and this. Now, I don't really know what you want to subtract first, but if I go back up here, it says the vertical change between those two graphs, so we've got 3 and f of x. So you can go f of x minus 3, or you can go 3 minus f of x. They did not specify, did they? Did they specify? Okay, so it kind of depends on how you set it up, but I won't let h of x be the vertical distance between the point x comma f of x and the horizontal line y equals 3. Find the rate of change with respect to x at x equals 2. I'm going to set it up 3 minus f of x. So that would be 3 minus 6 over 1 plus x squared. Now my question is, some people are going to ask, does it matter? Does it matter which way you would have done this? Will it matter?
Nah.
Well, you got to think about it, because if I go 3 minus f of x, 3 is always what? Above or below the graph? Always. Go back up here. Where is 3 at in relationship to that graph? Well, it's below between where? Nope, where is it? It's below before negative what? Negative 1 right here, and it's below after 1, but it's where? Between negative 1 and 1. Above. Okay, so it's going to depend. It's going to depend on that vertical distance. Sometimes it's negative. If I go 3 minus f of x, the distance between them is going to be positive when we're down here. Agreed? Okay, if I go 3 minus f of x, the distance is going to be what? Above here.
Negative.
But if I flip-flopped it, if I went f of x minus 3, we'll just flip everything?
Yeah.
So does it really matter which way we do it? No, we'll be able to interpret based on how we set it up. Okay? It'll work itself out. So if you did it the other way, don't worry, you're going to get the same answers. All right, so now we're just going to take, it says, find the derivative with respect. By the way, that was 1 point, just writing the equation, 3 minus 6 over 1 plus x squared. That was 1 point. Guess what the next point's going to be?
Evaluating?
Nope.
Plugging it into the root.
Well, we got to do what first? Take the derivative, and guess what? You get a point for taking the derivative. All right, here we go. What's the derivative of 3? 0. What's the derivative of negative 6? It's up to you. How many of you would do quotient rule?
I'd probably do chain rule.
I would do chain rule. Because this is really 3 minus 6 times 1 plus x squared to the what? I would definitely do chain rule. Don't do quotient rule unless you have to. So we're going to get the derivative of 3 is 0, agreed? We're going to get negative 1 times negative 6, which is 6 times 1 plus x squared to the what? Times 2x. So we get our derivative is 12 times, or we put 12 over 1 plus x squared to the second power.
Where did 12x go?
12x, thank you. Oh, I now know why they went 3 minus f of x. Because at x equals 2, which one was on top? At x equals 2, which one was on top? The 3. That's why they did 3 minus f of x. So it did matter because at x equals 2, 3 is the top function. All right, then what's the last step here? And that's a point. That'll be a third point. Plug in 2. So you're going to have 12 times 2 over 1 plus 2 squared. That'll be 24 over 5 squared. So you're going to get 24 over 25. That is a point. So you got 3 points for that problem. 1 point for writing the equation, 3 minus f of x. 1 point for finding the derivative, and 1 point for the answer. Is that good? All right, go to 5. Differential equation. Here we go. Differential equation. Diffie cube. Yay. Hey, I like these. 40 minutes. I know. It's going to... All right, you ready? Blink, everybody. See you Tuesday. And we'll be saying it. See you a week, 10 days from now, and we're going to be like, golly, that week and a half went by quick.
I'm in movies.
And then we're going to watch movies.
That depends on-
And then blink again, and you'll be 40.
Yeah, we can't see, so.
And you think I'm joking. It feels like 5 minutes ago I was in high school. Five minutes ago. All right, during a chemical reaction. I can literally think back to the moment I was walking across graduation stage right now. This second, it feels like a second ago. All right.
You were probably the valedictorian, weren't you?
No, I was 13th in my class out of 284. Hey, life's like a roll of toilet paper. No, life's like a roll of toilet paper. The closer you get to the end, the faster it goes. All right, during a chemical reaction. Yeah, especially when you're in a public restroom. All right, during a chemical reaction, the function y equals f of t models the amount of a substance present in grams at, Did you get it finally?
Great analogy.
It was.
Wait, what's
Great
the
analogy.
public?
It's like roll ball.
Nobody wants to have a short roll in the public restroom.
You always got checked.
Yeah, you always got to check. You got to make sure it's a big roll. Okay?
Always checked.
I'm
Is
just
this
gonna
gonna spin or what's
Anyways. Shh. All right, during a chemical reaction, refocus. Shh, refocus. During a chemical reaction, the function y equals f of t models the amount of a substance present in grams. How much present in what? Grams. At t seconds. The start of the reaction, here we go, underline this. At the start of the reaction, t equals 0, there are how many grams present? There's a start value. If I have to do start plus displacement, I got it. If I got to find a plus c, can I find it? Yes. The function y equals f of t satisfies the differential equation here. Now, that's not the differential equation I memorized. The differential equation you memorized for your calculus essentials was this. Let's see who remembers it. Y is equal to what? CE to the KT. Very good.
I got that one right.
Okay, good, because you missed the other 8. All right, so dy dt is equal to negative 0.02 y squared. All right, part A is worth 2 points, and it's free. Use the tangent line of y equals f of t at t equals 0 to approximate the substance at t equals 2. So we want to use the tangent line. Can you write an equation for a tangent line? First of all, do we have the point at 0?
Yes.
What is the point at 0?
10.
0, 10. Now, can we find the slope of the tangent line? Yes, you can. Do you have the derivative right now? You have dy dt. So all you got to do is plug what in to get dy dt, the slope at 0. What do you got to do? You just got to plug 0 into dy dt. So if I plug 0 at t equals 0, wait a second here. There is no t to plug into. There's only a y. So I'm not actually plugging in 0. What am I plugging in?
Why?
What is y at 0? You need to plug in the 10. That was a little shysty.
Ooh.
And you get this answer? That is 1 point. So if you get this, watch this. It's a decimal without a calculator. Blake, I'll help you. Don't worry, I'm good at this. 100. Guess what? When you multiply a decimal by 100, it moves the decimal 2 places to the?
Left, right.
How about right? So it's -2. There's my slope. That was worth 1 point. So do you have your slope? Do you have your point? Can I write the equation for y? What's the original equation, or what's the tangent line equation? We're using the tangent line to approximate y equals f of t. So y minus what? y1, y minus 10 equals -2 times x minus 0. Now, I'd probably go ahead and set it equal to y. So you're going to have y equals -2x. Can anybody tell me -2x what? Plus 10. And they want me to approximate at 2 seconds. So I want to see how many grams of substance there is at 2 seconds using the tangent line to approximate. Because the tangent line close to 0, if you're pretty close to 0, even though it's either going to be, the tangent line is going to be a little bit above. So like, let's say it's 0. Right here is t equals 0. And let's say the tangent line looks something, well, it's -2. Let's make it more realistic. Let's put it right here. So there's t equals 0. And so tangent line looks something like this. And this is t equals 2. Is the tangent line pretty close to the same value? Is it off a little bit?
Yes.
But is it close? Now, the further you get away from the point of tangency, what happens to your approximation? It gets further away and it's not as good. So if you stay within a couple of values, you're going to be pretty close. So y equals -2 times 2 plus 10, easy second point. So that's going to be 6. There you go. And that's 6 grams. You want to put grams there. All right, let's go to the next part. The next part is just 1 point. Using the differential equation, determine whether the graph of y could resemble the following graph. Give a reason for your answer. All right, so they have dy dt. Let's write this down. The differential equation was negative. This is those rules for, all right. This is rules for slope fields kind of thing. All right, this is your differential equation here. But they're saying this is the original graph, which the original graph, remember, has to follow the what? In the slope field, what does the original graph have to do? It's got to follow the slopes, right? Now, this is your differential equation. This is actually really easy, and it's only worth 1 point. You're in what quadrant here for this graph? What do you know about y in quadrant 1?
Positive.
It's positive. If you plug a positive in here, what is that going to tell you? It's going to tell me that my graph is always what? Decreasing. So we could say, so is this graph always decreasing though? Because if I plug in a positive y, any point you plug in quadrant 1, it's a positive y, agreed? If you plug it in here, dy dt is going to be what? Dy dt is negative according to this graph. Agreed? So that means if it's negative, it's always decreasing. Is this graph always decreasing? So could this be a possible graph? The answer is no. You would say the graph of f cannot resemble the given graph because the given graph is increasing for a portion of its domain. And it's supposed to be always what? Decreasing. Okay? That was 1 point. You might get it, you might not. Now, I'm going to be confident that a lot of you are going to get a lot of points on the next one. I think most of you are going to get 3 of the 4. This is a differential equation. Solve it. Okay, what is the first step to solve a differential equation? And they did give you a start value.
You gotta separate the variables.
All right, that's going to be 1 point, separation of variables. Everybody ready? So here we go. We got dy dt is going to be equal to negative 0.02 y squared. All right, how do we separate the variables? Step 1. Multiply by dt and?
Integrate.
No? Okay, let's just multiply by dt and see if we've separated those variables.
Oh, I get it now.
Have I separated the variables?
Yes. Divide by
Really?
y
I've separated the variables.
squared.
I need to get the y squared over. So now we're going to have 1 over y squared dy is equal to negative 0.02 dt. Now you get 1 point. I'm going to put 1. 1 point right there. What's the next step?
Integrate.
Integrate. And you're going to get 1 point for doing the antiderivatives correctly. I would go ahead and make that y to the negative 2 so I can use simple power rule. And then the other side is just a constant, so that'll be easy. So somebody tell me, first of all, what's the antiderivative of y to the negative 2? What's the rule in reverse? Add one back. And multiply by the reciprocal or divide by the new exponent, whatever you want to do. If I divide by -1, is it just going to make it negative? So I'm just going to put a negative. Is there a plus c?
Yeah, well,
But what can I do? Put it on the other side. What's the other side? What's the antiderivative of negative 0.02? Just a constant. Negative 0.02 what? And not x. T. Plus. All right. You ready? You're 2 points now. Because you did the antiderivatives correctly. What's the third point? Sometimes they actually give you 2 points here if the antiderivatives would have been harder. If there would have been one that used like integration by substitution on one of the sides, or if it would have been like a more complicated antiderivative, sometimes they'll give you a point for each antiderivative. But this one's really easy, so they're only giving you 1 point to get both antiderivatives. But there is one more point here you can get that I'm confident everybody can get. Find C. How do you find C? Now, if you plug it in right now, that's fine. I'm totally fine with you plugging it in right now. If you want to solve it a little bit more, that's fine too. It's up to you. I'm going to do one thing. I'm going to get rid of the negative at least. Can I do that at least? So I'm going to have 1 over y equals positive 0.02t, and it's still going to be a plus c. Would you be okay with that? Now, I'm going to go ahead and plug in the point. Might as well, right? So, because at least I can get the c. What do I plug in for y? 10. What do I plug in for t? Oh, that's nice. So what does c equal? That's a third point. The final point is the hardest point, and that's getting the original equation. So now I'm going to go back right before I plugged in for the plus c, the step before I plugged in to find the plus c, and I'm going to go back and put my c in and solve for y. So this is where Blake's going to have to work for this one. This one's not too bad, though. You're going to have 1 over y equals 0.02t plus 1/10. All right. I need you to solve for y.
Or just flop them like the y outside.
You could flip both sides entirely, but they're going to get they're going to want this equation fairly simplified. So it's kind of up to you. One thing you can do is you've got decimals and fractions. I would either go with all fractions or all decimals. So what do you want to do? Okay, fine. 1 over y is equal to 0.02t. What is 1/10 as a decimal? 0.1. Now it's pretty easy to flip both sides. Would you agree? So be y equals 1 over 0.02t plus 0.1. They're probably going to give you a point for that. But if you want, like everybody would know, this is 1 over... I'm having a brain fart. What is 0.02 as a fraction? Good gravy. It's 1/50th, right? Okay, I was second guessing myself. 1/50th t. Okay, and then what they might do is they might multiply the top and bottom by the least common denominator, which is what? You're not allowed to leave fractions in a fraction. So in the multiple choice, I'm just saying if you ran in multiple, this is fine on the free response. But if you ran into this multiple choice, they might not have that decimal answer. They might actually have it in fractions, and then they might get rid of the fractions. What do you multiply top and bottom by to get rid of the fractions? 50. So you would end up with 50 over t plus 5. That's probably what they'd have as a multiple choice. But this is a little hard for the multiple choice. They just don't take this long on the multiple choice, so this is probably not on there. So the decimal one is fine, though. All right, second one. Determine... I love this. Determine whether the amount of the substance is changing at an increase or decreasing rate. If you have dy dt, you already have the rate, right? You already have the first derivative. What was it? dy dt equals what? What was it? Negative, tell me what it was. Negative 0.02. We're almost there, guys. Okay. Is that okay? Okay? This is the first derivative, agreed? They want to know, determine whether the amount of the substance is at an increasing or a decreasing rate. Explain. Well, what would you need to know to be able to figure out if this rate is increasing or decreasing?
Whether it's positive or negative.
You need to know where what is positive or negative.
The OG.
Nope. I'm going to ask you again. Determine whether the amount of the substance is changing at an increasing or decreasing rate. We're at the rate. I want to know, is the rate increasing or decreasing? You need the second derivative. Now, this brings in implicit differentiation right here on this problem. Because it's dy dt. You're doing dy dt, you're taking the derivative of t, but there is no t on the other side. What is there? You need implicit differentiation. So it'd be d squared y over dt squared is equal to, now we're going to do normal derivative, but then when we get to y, we got to multiply by what? Dy dt. So it's going to be negative 0.04 y times what? Dy dt. Now I want to figure out, is this going to be increasing or a decreasing rate? Now, do you remember when we did a second derivative implicitly? It's been a while. I said there's always a what?
You can plug it back in always?
There's always a back substitution you have to do. Anybody see what I can plug back in?
The negative 0.0.
This can go in for the dy dt. That will always be there. That's always there. The first back substitution's always there. There's also an OG substitution, but are we going to do an OG substitution? We don't even know what the OG is. So you are going to do that, and here's why you need to do that, because I need to figure out, is this going to be an increasing rate or a decreasing rate? So what I'm going to do is negative 0.04y times, ready? Negative 0.02y squared, which will give me what? Positive, that's key, positive 0. How many decimal places are there going to be now? I've got 2 here and I've got 2 here. Just multiply 4 times 2. What's 4 times 2? But how many decimal places are there total now? 4. You need 4 decimal places. So 0.0008 y to the what? That's 1 point there. That's 1 point. Now your answer. Okay?
Was it 88 grams?
Since y is the amount of the substance in grams, what would you assume y is always? Would you assume that we can't have a negative amount of a substance? So because we're talking about the amount of the substance in grams, we would assume that y is always what? Since y is always positive, and if you take a positive and cube it and multiply it by a positive, you would assume the rate is not. Is this rate, is it increasing? Is it an increasing rate or a decreasing rate? It's an increasing rate. Which would tell you, by the way, that the original function is concave what? Up, if they wanted to know. So this is an increasing rate because you would have to say, in your reason, you would say, because y is greater than 0, because it's the amount of a substance, because y is greater than 0, 0.0008y cubed would also be positive, so it's an increasing rate. Okay? All right, one more. And then if you want, we can call it good. I know you're tired. I don't know if doing 4 or 5 multiple choice questions is going to be a benefit. Right now, we're through that tired. Okay, here we go. Consider the curve. All right, right out of the gate, I can tell this is what kind of problem. Can anybody tell what kind of problem this is right now? You got dy dx, and you got 2 over 2 minus sine y. It's an implicit, it's going to involve some kind of implicit differentiation. If it's not set equal to y, it's probably in an implicit differentiation problem. Here we go. Let's get this one done. Focus all the way in the end, we'll call it good. Consider the curve given by the equation 2 times x minus y equals 3 plus cosine y. So they give you a curve. So this is an OG equation. Or some kind of original equation. I don't know if it relates to this one yet. I don't know. For all points on the curve, dy dx is going to be between what for slopes? Remember, dy dx represents slope of the tangent line. So they're saying the slope of the tangent line is always between what?
2/3 of the
So is the slope of the tangent line ever negative?
No.
So the derivative is always what?
Positive.
All right. This says show that dy dx equals this. Okay, now all I want to do, I've got the OG equation. I want to show the derivative of this is what? That. They want you to prove it.
You just gotta take the derivative of it?
You got to take derivative and get to this. Now, some people are like, can I just wrote I did a derivative and say it equals that? No, you got to prove it. So you have to show it with a correct derivative step and correct algebra step. It's always worth 2 points. Okay, it will be 2 points here. Okay, I think. Yep, it's 2 points. So here we go. Who would like to try to take the derivative of this implicitly? 2 times x minus y equals 3 plus cosine y. Who wants to try it? Who wants to practice?
I need it.
Go ahead.
Okay.
Start with the left side.
2, or no.
Yeah, 2. Don't.
2 times x.
What's the derivative of x?
1 minus 1 dy dx.
There you go. Y you got to do implicitly. Equals.
3.
Oh, what's the derivative of 3?
0.
0. What's the derivative of cosine y?
Negative sine y dy dx.
Times dy dx. Very good. That's it. That's 1 point right there.
W in the end of it.
All right, that's 1 point. Now I've got to manipulate this and make it look like this. That's like trigonometric proofs we did last year. I got to get the dy dx to one side. So, first of all, I'm going to underline it. You got a dy dx here, and I got a dy dx here. Think 8th and 9th grade algebra.
Distribute right away.
I would distribute the 2. So you got 2 minus 2 dy dx. Very good. We somehow got to get the dy dx to one side. Okay, you're almost there.
Divide.
Nope, never divide. Not until the very end.
Oh.
You gotta subtract.
What'd you say, Ellie?
I didn't say that.
Somebody said it. Elsa?
Subtract the 2.
Oh, Jaden. Not, you could, but I don't know. That we just distributed it.
Yeah, add sine y.
You could add the sine y, but I would probably, because you got the 2 over here. So you got the right idea. I'd add the 2 dy dx. Is that okay?
Sure.
So we're going to get 2 is equal to negative sine y dy dx plus 2 dy dx. We can switch signs and all that in a minute. Now, why did you get the dy dx to one side? This is the crux move. So you can take the dy dx. Now you do what you wanted to do, Jade. Now you want to factor it out. Now you take the dy dx out. So you got dy dx is equal to, or times, dy dx times negative sine y plus 2. Now, have you got the dy dx by itself? Now do what, Bjorn?
Divide.
Now divide by the negative sine y plus 2. Negative sine y plus 2. Does that look like what we want it to look like? Really close. Is it close? So can I just rearrange it and say dy dx is going to equal 2 over, can I just rearrange it so instead of going negative sine y plus 2, write 2 minus sine y? Is that legal? There you go. You verified it. That was 2 points. And you don't have to show every little step algebra. You do need to show that you're getting the dy dx to one side and factoring it out. You could have done that in one step and then divide. Okay? All right, part B. We're almost there. From negative pi over 2 to pi over 2. Must be some trig involved. There is a point P on the curve through which the line tangent to the curve has a slope of what? Everybody, what does it have a slope of? 1. All right, there is a point in which the line tangent to the curve has a slope of what? So that's where the what equals what? I'm going to say it.
Is that wrong?
Nope. I'm going to read again. From negative pi over 2 to pi over 2, there's a point P on the curve where the line tangent, the tangent line, has a slope of what? So what do you want to do?
Yeah.
What do you want to do?
Says something equal to 1.
Yes, what do you set equal to 1? We're almost there. Tangent line. Not tangent line, but the slope of the tangent line. What's the slope of the tangent line in this problem?
2 over 2 minus sine.
2.
That. You have the derivative. In fact, listen. In fact, part A, you don't even have to be able to do part A to do part B because they already gave you the derivative. You know the derivative from part A. You could have skipped part A altogether and done part B because all they want to know is when the slope is equal to what?
1.
The slope is the derivative. So I want to know when dy dx equals 1. So I'm going to take what I just did, which was 2 over 2 minus sine y, and set it equal to what? 1. Now what do we do? Now you know what to do. multiply by 2 minus sine y. So we're going to have 2 equals 2 minus sine y. Now solve for sine y. Come on. Subtract 2. That gives me 0 equals negative sine y. Does the negative matter anymore? So 0 equals sine y. Now there was a reason they gave you from negative pi over 2 to pi over 2. This one, you did not need to know that arc sine, the restriction was negative pi over 2 to pi over 2. Because guess what? They what? Gave it to you. So when you do arc sine, you need to make sure your answers are between negative pi over 2 to pi over 2. So here we go. So we're going to take the inverse sine of both sides. So I need to figure out where sine equals 0. So from negative pi over 2 down here to pi over 2 up here. So from here to here. So clockwise this way, counterclockwise this way. Where is sine equal to 0? Sine is the what on the unit circle? The y. So where is the y equal to 0? Here, here, or here?
Here.
Right there. Is everybody agree? So what is it? 0. The answer is y equals 0. Okay, guess what? That's 2 points. And here's the coolest part. You got 1 point for just doing that. For knowing slope equals 1, you knew to set dy dx equal to 1. Either here or here. Doesn't matter which one you do. You set it equal to 1, that's a point. The answer was also 0.0. And they only wanted the y. Now, oh wait, we got to finish it because they wanted the whole point. So do we have the y value? We got to go back. Where do you get the original? Where do you get the point? You always got to plug into the what? The OG. Do we have the OG?
Yes.
Right there. So we can plug in, it's 2 times x minus y, I'm trying to go fast, is equal to, what is it? 3 plus cosine y. That's the OG. Because they want the point. It says, find a point, point P. We got the y value, so plug y equals 0 in. So we're going to have 2 times x minus 0 is equal to 3 plus cosine of 0. All right, we got 2x is equal to 3 plus, Blake, what's cosine of 0? 1. So we got 2x is equal to 4. What does x equal? So what's the point? There you go. That was 2 points. All right, 2 more. All right, determine the concavity. What do you need for concavity? What derivative? Don't I already have the first? Did I even need to be able to do part A to do part C? Why? Because didn't they just give you the derivative in part A? What was the derivative from part A? 2 over what? 2 over 2 minus sine y. All right, we want to take the what? Derivative to get to the second derivative, and I want to know the concavity from negative pi over 2 to pi over 2. So we're doing a sign analysis now. All right, here we go. Second derivative. Here we go. This one's worth 3 points. 3. Okay, and you're going to get 2 points for finding the second derivative correctly with the back substitution. Here we go. Second derivative of y with respect to x the second time. All right, this is super nice. Would you use quotient rule?
No.
I wouldn't. What would you do? Bring it up top and use what rule? I'd use chain rule. That's to the -1. All right. That's going to end up being, ready? -2 times 2 minus sine y to the what power? Times the derivative of the inside. Now, when we do the derivative of the inside, remember, when we get to y, we got to do it implicitly. All right, what's the derivative of 2? 0. What's the derivative of negative sine y? Negative cosine y times what? dy dx. That right there is 1 point. Now, if you simplify the second derivative correctly, you're going to get a second point. Are you ready? Here we go. I'm going to do a back substitution. What's the back substitution I can do?
Plug it in 2 over 2 minus sine y.
Plug that in for dy dx. So we're going to have, let's see, I'm going to go -2 times negative cosine is +2 cosine. Does everybody agree with that? Over 2 minus sine y to the what power? Second, times dy dx, which is 2 over 2 minus sine y. Oh, that's good news. So then I'm going to end up with 4 cosine y over 2 minus sine y quantity what? Cubed. Now, that is my second derivative. That is 2 points. Now, we only want to know from negative pi over 2 to pi over 2. You would real quick have to do critical values. Is first of all, cosine, 4 cosine y equal to 0. Let's just do critical values real quick. That's going to give you cosine y is equal to 0. We already know we got to go from negative pi over 2 to pi over 2, but we want to see, do we have to break this up anymore? Where's cosine equals 0?
At 0.
Nope.
Power 2.
Aren't those already values? So did that help me?
No.
Nope. So now the bottom equal to 0. If I go 2 minus sine y is equal to 0, I'm going to get 2 is equal to sine y. On the unit circle, does sine ever equal 2? So does that give me any critical values? So are there any critical values? So this is either all concave up or it's all concave what? How do you know? You're going to take a value, plug it in here. Let's just plug in 0. Can we just plug in 0? Is that easy enough? If I plug 0 into the top, what's 4 times cosine of 0? We said cosine of 0 was what? 1. What's 4 times 1? That's a positive, right? Plug in 0. What's sine of 0? Yeah, is sine of 0, 0? Yep, sine of 0, 0. 2 minus 0, 2 to the third. Positive, positive divided by positive. So you would say the second derivative is positive, therefore the original function is concave what? Everywhere. It's concave up over the entire interval from negative pi over 2 to pi over 2. How many feel like you understand that? That makes sense? Are you following this?
What was the explanation again?
You would just say because d squared y over dx squared is greater than 0 in the interval, we'll just say from negative pi over 2 to what? The curve is what? The curve is concave up. Concave up. All right, last part. Good job. You guys are doing awesome. I know it's hard. I get it. I can imagine. I've done all-nighters before. It sucks. All right. Let y equal, that's why when my wife asked me to help with lock-ins at the church, I'm like, no, not anymore. I'm almost 50. No, thank you. Y equals f of x. Okay, defined implicitly. All right, back to that original equation. Now here's what it says. Let y equals f of x defined implicitly by 2 times x minus y equals 3 plus cosine x y. Cosine y. This is a really good problem. All right, we're done here after this problem. So listen, this is a really good one because you are guaranteed every year this is going to be one part of a free response in problem 1 through 6. One part, you're going to have a theorem problem. It's either going to be, we've already did an EVT. You're either going to run into an IVT on a multiple choice for free response, but I guarantee you're going to run into an MVT on the free response. Okay? That is continuous on the closed and differentiable on the open. Isn't that just automatically MVT? All right, you memorized it for the calculus essentials. What does MVT guarantee? IROC equal to what? So all I got to do is say dy dx has to equal f of b minus f of a over what? B minus a. Okay, that's what it guarantees. Agreed? All right, so let's look at it. They gave us a closed interval, 2 to 2.1. So I want to say there's some value. We'll call it C. Can I call it C? So there's some value C, f prime of C, that is equal to f of what? 2.1 minus what?
2.
Over what? 2.1 minus 2, which is what? 0.1. Does everybody agree with that? Now, there was something they told you all the way back in the original problem. What did they tell you about dy dx? The slope was always between 2/3 and what? And 2. So it was always a slope between. So I'm going to go back to that. There was a reason they gave you that. The slope, dy dx, was always between, what was it, 2/3 and 2? All right, because we're going to need that now. All right, so if the derivative, if f prime of x is always between 2/3 and 2, says use the min value theorem on the interval from negative 2 to 2.1 to show that 1/15 has to be less than or equal to f of 2.1 minus f of 2 less than or equal to 1/5. All right, so here's what we're going to do. We have this right here. We have that inequality right there. And we're saying that somewhere, because of MVT, this is guaranteed. Agreed? So we're saying that 2/3 is less than or equal to f of 2.1 minus f of 2. By the way, you've already gotten a point for showing the AROC equals the IROC because you did the MVT part. You already got a point for this. You got 1 point for showing that there has to be a place where the slope of the tangent equals the slope of the what? This I rock equal to A rock. So you got 1 point for that. Now I'm using this inequality statement. Now watch carefully. This is actually pretty easy. I want to show, it says it wants us to show this. Well, we're almost there. All I got to do to solve for f of 2.1 minus f of 2 is do what? Multiply both sides by what? I got to multiply this by 0.1 and this by 0.1. And let's see if it equals that. And if it does, we're good to go. That'll cancel. So less than or equal to f of 2.1 minus f of 2 less than or equal to, what's 2 times 0.1? 0.2. What is 0.2 as a fraction? 1/5. And if you wanted to change that to 1/10 and do 2 times 1/10 is 1/5, you could have done it that way. Because if you don't know what 0.2 is. Okay? All right, what's 2/3 times 0.1? That one might be a little harder. That might be make more sense to say 0.1 is 1/10 times 2/3. What happens? What do you get?
2 tens cancel. You get a
The 2 cancels, the 10 cancels to a 5. What do you get? Did we show it? There you go. That's the final point. Just had to verify it.